the proof of...
Sir, did you say anything? Sorry, my Wi-Fi again went in the middle.
No problem. I was just telling we arrange one extra class from 6:30 to 8:30. Those students who have exams on Sunday can attend it first and have their doubts and leave the meeting. No problem. So that is what we were discussing. Anyway, the proof of balanced condition of wheatstone. Yes, हो सकता है कि you might not understand what I am speaking, but take the feel of 12th grade classes, है ना?
Yeah.
Proof of balanced condition of wheatstone. And by the way, this derivation is important from school point of view. So let us consider a wheatstone bridge like this, in which how many resistors are connected? 5 resistors are connected as shown. Let's name those resistance: A, B, P, Q, R, N. Let's say it is connected to a battery of how many volts? V volts. Okay. Yes. Can anyone distribute the current? I'm proving it using KVL. Okay. Kirchhoff's voltage law. So let us say a current I comes out of the battery. When this current I comes out of the battery, it reaches to point A and it reaches to this junction, right? When it reaches to this junction, what will happen? Will it divide into two parts?
Yes, sir.
So it divides
Yes,
into
sir.
two parts. Let's say this is how much? I1.
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 I minus
I2.
I1.
I minus I1. So this I minus I1 current flows through Q. This I1 current flows through here. When this current reaches over here, let's say what is the current over here?
I1.
I1 is the current.
Okay, yeah, sorry.
So this becomes I2 and
I2.
this will be I1
Minus I.
minus I2.
Minus
I1.
I2.
So this I1 minus I2 will pass through here and I minus I1 will pass through here. They both will combine and become I minus I2 over here.
I2.
Yes, are you understanding what exactly we are doing? We have split the current at this particular point. 10th grade physics, if you remember. The current is split at the junction. So if I out of I1 current is going in this branch. So the remaining, can you see I minus I1 will go in this branch.
Yeah.
And here in this case, what is happening? I1 minus I2 current is coming from here. I minus I1 current is coming from here. So they will combine together. So I added both of them. When I add this, can you see I1 and I1 will get cancelled and I minus I2 will.
Yeah.
Now this I2 current is coming from the upper branch and I minus I2 coming from this branch. Tell me what will they combine and get?
I2.
I2 and I2 will get cancelled. I minus I2 and I2. When you add this I2 and I2 will cancel. I minus I2 plus I2 is how much? I2 and I2 getting cancelled. Right? So basically I current will come back to the back. Is this clear? Is this clear? This the current distribution, guys. Everyone?
Yes.
Yes. Now can
Yes, sir.
make the equations? I'll just name all the points again. Let's say this is your A point. This is your B point. This is your X, and this is your Y. Is this clear? Okay. Now, can anyone apply KVL? Let's apply KVL to loop A, X, Y. Yes. From here. Shall I write the equation directly? Everyone is comfortable in this thing. We are applying Kirchhoff's voltage law. Don't worry, I'll take an extra class so that at least I'll share the lectures. You just sit back and relax. कि देखो आज क्या क्या हो रहा है. Okay. You might not get a single word of this what is happening, but थोड़ा बहुत try to relate it with 10th grade. Okay. 10th grade intensity. So A X Y A. Now tell me this particular thing. If yes, Abel, will you be able to tell me the equation? Abel? Hello. Guys, can you please unmute your phone? Everyone. Yes, guys, please kindly unmute. Satvik, Shrish, Pavitra, Joysa, Darian, Abel, please unmute. Yes. So, Darian, can you tell me the equation? Abel is not replying.
Minus
PI1.
PI1.
So
P.
I1P minus I1 minus I2 times T plus I minus I1 times Q.
Is everyone getting this equation?
Yes, sir.
Yes, sir.
Okay.
Yes.
Can anyone tell me what about the loop x bf y x?
Minus
Minus R I2.
I2
minus
R.
R on 2
So minus I2 into R plus I1
S
R
into
I1 I into I
S.
minus I2
plus
plus T
I1
into.
minus.
plus
This is I minus I2, right?
yes I minus I. Sir.
I minus I2.
And I1 minus I2
T.
equals.
T.
Yes or no?
Yes,
Yes,
sir.
sir.
Can you tell me what is this? Solve, collect all the terms. But here there is I also, I1 also, I2 also. So I want the term for I. I want the term for I1. And I want the term for I2. Yes. So I think Q is into I, right? QI, right?
Yes, sir.
So plus Q
Yes.
into I. उसके बाद can you see I1 it is minus P, minus T and minus Q. Yes or no?
Yes, sir.
So can I write minus common P plus Q plus P? Yes or no?
Yes, sir.
Okay. And what about the last one? I2?
T plus TI2.
Plus TI2, huh?
So plus PI2 equals to 0.
0.
Yes, sir.
Similarly here,
So IS
SI plus
minus
R
I2
plus
times R plus S
plus
plus P.
I1 first,
yeah
I1
I1 is I1
plus
minus
TI
plus
I1T.
PI1 plus what about I2?
minus S plus R plus TI2.
Minus of S plus R plus, you got it? Equals. Okay. The third condition is also there, but it is not required because we want to just make it this thing. So for no current to flow in the branch having the resistor T, which current should be zero? If we don't want to make any current flow through this, then which current should be zero? I1 minus I2 should
I1
be zero, right?
minus
Minus
I2.
I2.
Minus I2.
Yes, sir.
So that for this to happen, I1 minus I2 should be equal to 0. That implies I1 should be equals to I2.
I2.
Can you use this equation in the both equations over here? 1 and 2. Can you use this equation number 3 in 1 and 2? So can you see over here, this equation this equation will become, if you put I1 and I2 equal, so can you see I1 and I2 are equal, so this will become minus P plus Q, right? Can I write
Yes,
this
sir.
equation as Qi minus, can you see here there is a minus T over here, can you see minus T over here, will get cancelled with this plus T, and what will remain? Only P plus Q will remain, right?
Plus Q.
Into I1 is equals to 0. Can everyone solve for I from this equation? I will be equals to P plus Q upon
Q by
Q into I. Yes or no? Similarly, what about the
Yes, sir.
second equation? What about the second equation? Okay, basically, we are solving this equation. This is important school point of view, so that's why I'm writing the whole thing. Otherwise, I would have kept the equation solving part. Can you see the same thing happens over here? T and T will get cancelled out. Yes or no?
Yes, sir.
And what will remain over here? S into I
Si
minus
minus S
plus
plus
R.
R I2.
I2 is equals to
I2.
0, right? Or let it be I1, no? Why writing I2? I1. So from here, can I write I is basically equals to S plus R upon?
S plus R by R.
So can you see from equation 4, both are equal to I. So can I equate them? So P
Yes, sir.
plus Q by Q will be equals to S plus R by S. Can I divide? Will it be 1 plus, sorry, P plus P by Q plus 1 will be equals to 1 plus R by S. Yes or no? That implies.
Mhm.
Any doubt? Hence, so this is your condition. So can you see from the given condition, we got this result. So the reverse is also true. So converse is also true, right? Yes or no, guys?
Yes, sir.
Yes.
Yes, sir.
This is your derivation for Wheatstone bridge. Balance the condition. Okay? Write it.
Can you please scroll up a
Yeah,
bit?
sure. यहाँ तक? यहाँ से?
Yes, sir.
चलो, शुरू में. So then make it small. I'll just do it again. Is it clear now? Shall I start a little bit, writing a little bit small? So at least everything will be in the page. Nothing will go on. So did you understand how did we do the derivation? It's easy, right? For one condition to follow, you'll get the second condition. So the converse is also true. So whenever P by Q equals to R by S, no current will flow in the branch with the resistor. Is this clear? Is this clear, guys? Everyone note it down? Hello?
Yes, sir.
Let's start with done. Everyone done?
Yes,
Yes.
sir.
Yes, sir.
Yeah.
So now let's do some questions based on balanced conditions. So let's start with a simple one. Yes, do you remember the series parallel connection?
Yeah, somewhat.
Yes, sir.
So can you see a circuit like this? Alright, I'm starting with the basics, just apply. कैसे apply करोगे? I need to see that. So see over here, can you see the ratio over here? What is the net resistance over here? What is P? What is P? P is basically this one, right?
Hmm.
And what about this? Q?
You.
2 ohm, right? 1 ohm plus 1 ohm, 2 ohm. Series connection we added. What about
Yes.
R?
0.5.
0.5.
0.5.
0.1.
And what about S? So can you see over here P is 1 ohm. So P by Q is 1 by 2 and R by S is also
1/2.
1 by 2. So hence no current will flow through this resistor.
5.
So let's remove it from the circuit and the circuit will become like, I'll provide it. So the circuit will become like 1 ohm, this is 0.5 ohm, and this will become 2 ohm and 1 ohm. Is this clear? So can
Yes,
anyone
sir.
tell me the net resistance,
sir.
R net? And this will be R double dash. So what will be the net resistance? R dash into R double dash. We are using the parallel formula, okay? Yes, do you remember this thing?
Yeah.
1 by R.
Yes, yes, I remember that.
Yes, R1, R2 upon R1 plus R2.
Yeah.
We are doing that only. So R dash plus R double dash. So 1.5 into 3 upon 1.4.5. So 1, 3, the net resistance. Is this clear, guys?
Yes, sir.
Yes, sir.
So this is one very basic question which I will given. So do this. How will you deal with this? Tell me. this is 1 ohm, this is 2 ohm, this is 3 ohm, this is 2 ohm, this is 4 ohm, this is 6 ohm. And both of these are 10 ohm, 10 ohm. So this is also Wheatstone, but think how will we do it? Does it exactly look like a Wheatstone? Is it having only 5 resistors?
Mm.
No. How will we do it? Basic, the Wheatstone was a concept. How we are dealing with this? This is the application. Okay? Then how will you do?
So can we consider it as two separate Wheatstone bridges?
Exactly. You need to consider it as two separate bits. Can you see the assembly of these five? These five.
Mm.
So what will be if you consider these five as your? You see there will be no current flowing in this channel. Yes or no? Yes or no?
Yes, sir.
And similarly, can you, if you consider this as your Wheatstone, you see again 1 by 2 here. In the previous case, it was 1 by 2 and 2 by 4. What is 2 by 4? 1 by 2. So P by Q is R by S, hence no current in this channel. Here it is 2 by 3 is 2 by 6. So hence no current in this channel. Are you getting my point? So basically, what happens
Yes, sir.
whenever this type of Wheatstone is there? Basically, it's still a balanced condition. So no current flows to here, no current flows to here. So the whole circuit becomes like, whole circuit becomes like. Like this. Is it clear? So now can you see from clearly over here, this 1 ohm and 2 ohm is in series, 2 ohm and 4 ohm is in series, 3 ohm and 6 ohm is in series, and all of them are in
Parallel.
parallel. So 1 by R net will be 1 by 3 plus 1 by 6 plus 1 by. And then you can solve. Okay? Is this question also clear?
Yes, sir.
Okay. Next. Are you drawing along with me? Keep on writing. There are lots of applications of Wheatstone. अभी मजा तब आएगा जब everything will start unbalanced. We'll start with the unbalanced. So try to put it down, and once you're done with this, then try this question. I won't be helping you out. To figure it out. Can you see a triangle full of resistors? Yes or no? Every resistance is R. The question is find the net resistance across. Okay, find it, and let me just bring my calculator now. ये आपके बैग में हो तो बैग खोल देना। हेलो हेलो
Yes, sir.
फ्रॉम सात्विक वन किसका? सात्विक, इज योर माइक वर्किंग? previous to previous this one. अच्छा अच्छा अच्छा, okay okay. No, I just saw it. Okay, what is the answer for this one?
So is it R itself?
Is it a what?
Oh, for the top one?
No, the top one is basically this. That is 1. I'm asking for the second question which I gave. 1 by 3 plus 1 by 6 plus 1 by
So is it
3 by 2.
0.72.
what?
Is it 1.72 ohms?
1.6 seconds?
For this question,
The 3 by 2?
I don't know. Calculate karo na.
So is it 18 by 11? Like the
18.
fraction.
This will be 6.
So why you multiplying 18? Just multiply by. Okay, wait. Sorry. Yeah, got it.
18 by
11.
0.6.
है ना?
0.6.
You got what?
0.6.
0. Did you do 11 by 18? Tell me, you did that?
I think so. Yeah.
बेटा रेसिप्रोकेट कौन करेगा उसको? Full reciprocate.
Yeah.
So anyway, yes. What is the answer for this one?
R by 2.
R by 2 is the correct answer. Nice, Satvik, wrong. R by 2 is the correct answer. How? Yes, how did you do it? बोलो बोलो. Over your voice is not clear. Did you take this as your Wheatstone bridge? Can you see?
Yes, sir. I neglected the one in the between.
You neglected the one in the between. Yes, you have to do it like
Yeah.
this. Can you see the ratio P by Q is
Same.
1:1. R by S is also 1:1. So P by Q and R by S are equal. Hence, this circuit will become like. So if P by Q is equal to R by S, then no current will flow through this. So always remember, when no current flows through any resistor in the circuit, remove it from the circuit. Okay? So remove it. When we remove it, it becomes something like this. So R, and one more R. Right? So basically, can you see between points A and B, there will be now 3 resistors. Can you see? What is the net combination of these two? Can you see this?
2R.
2R. This is in, Yash, can you see
2R.
all of them are in series? 2R. This R and R is series. This R and R is series. And this is in parallel with all those. So what is the net
Yeah.
resistance? 1 by 2R plus 1 by 2R plus 1 by R. And which when you solve,
So why
R
have
by
we?
2.
I have a doubt.
ah,
Why have we neglected the one in the middle?
that is basically on the concept of Wheatstone bridge. Whenever 5 resistors are there, and if the ratio of these resistance is equal to the ratio of these resistances, then no current flows through this, the middle one.
Okay.
So that is why
Okay.
no current is flowing, so there is no point of keeping it in the circuit. It will make it look complex. So just remove it from the circuit. When you remove it from the circuit, it becomes like this, and then you solve after it. This is the balanced condition of Wheatstone bridge.
Okay.
Okay? Chalo,
Okay.
Patrick also got it. Nice. So is this clear, guys? Any doubt?
So what's the answer for this question?
R by 2.
Okay.
Always remember when all of the resistances are equal, then automatically suppose this is the Wheatstone bridge and all of the resistances are R. So even the answer is R. So R input is also equal to R1. If all the resistances are equal in a Wheatstone bridge, then the net resistance is also equal to the value of individual resistance. Is this clear? So this is one of the results. So anyways, any doubt in this? And the same concept can be applied to the capacitors as well. Let me just see if the question is there or not. It should be there in somewhere in the video. Just give me 2 minutes. Guys, what can you see? Can you see anything as of now?
No, so we can't see anything.
Yeah, Webex, whenever you minimize it goes black. Just 2 minutes. Give me 2 minutes. And by the way, I'll be giving you sheets today. My office was not activated, so that's why I couldn't give it now. I'll be giving you. I'll convert it into PDF today. And then I'll send some more questions to this one, apart from the TPP. Okay? Current capacitance. I think the question wasn't capacitance. The same concept of Wheatstone can be applied on capacitances as well. Yes, guys, do these questions. Can you see 2 circuits? Guys, can you see 2 circuits?
Yes, sir.
Yes.
They are based on Scissors method rather than SS method. So these are for your homework. Can you see the unnecessary wires involved?
Yes, sir.
So basically they are based on SS. Can you see the unnecessary wire? Even if there is one wire, still use it. Okay? Can you see one more wire? So these questions are based on SS method. If you wanted some more questions, so don't worry, I'll give you a sheet today. This the whole thing. So practice questions will be there. Note down these questions. And basically what do you need to do? What you needed to do in both the cases? Find the
Net capacitance.
perfect. But can you see it is including SS method? Whenever you're done noting down, just tell me. Now we'll discuss the unbalanced. This is not based on Wheatstone, okay? I wanted to give you some more questions on SS method, but I was not able to give at that time. But this will be like practice question. Whenever you're done noting down, done noting down, guys.
Yes, sir.
Everyone done noting down?
Yes, sir.
Yes.
Now write down unbalanced wheatstone. What will you do in the case of unbalanced wheatstone? Without any symmetry. So guys, see this particular thing. If suppose there are 5 resistances like this, is this your wheatstone bridge? Is this the same
Yes,
thing which
sir.
we drew? No, that if you remember, right? This is the same thing. I already drew the multiple circuits. P, Q, R, S, T, A, and B. So this is one and the same thing. So this is your points A and B, and these are your points X and Y. Is this clear? So this is also a wheatstone bridge. But please remember, now I am giving you unbalanced wheatstone. So for example, directly do with the help of a question how to solve it. Suppose there is a question and 5 ohm, 3 ohm, 2 ohm, 1 ohm. Either 2 ohm is bad. Okay guys, so can you see guys, this is a unbalanced wheatstone. Can you see any ratio pi by 2 is to 1, right? Is P by Q equals to R by S?
No, sir.
No, sir.
So answer should be no, because P by Q is basically equals to pi by 2, which is 5, and R by S is basically equals to P by 1. So they are not equal, right? Yes or no guys?
Yes,
So
sir.
we can't remove this 6 ohm resistor. If we can't remove this 6 ohm resistor, then how will we solve the question? The question is to find the net resistance across A and bit. And first is using KVL, and the second is using nodal analysis. So we'll do both. Please remember, no SS, no nothing can help you over here. Whenever you have an unbalanced wheatstone, directly use Kirchhoff and just give it to me. Yes, guys, one update is there. Maths class will start 15 minutes earlier. So the class will start from 4:15. Okay. Hello.
Yes, sir.
Okay, sir.
Maths will give this message to I'm giving it to you. So now what to do? First, let's start with using KVL. let's copy the question. So guys, if you are using KVL, who will distribute the current? Guru, can you distribute the current please? Hello? Guys, why do you keep on mute? I told you not to keep on mute. Everyone is on mute. Next time I'll do one thing, I'll not ask any. Simple. Guru, tell me. First thing, to throw, to flow current through it, you should connect it to battery, right?
Yes.
So assume you connect a 100-volt battery. Sir, why a 100-volt easier in calculation? Oh, ये मैं क्या कर रहा 100-volt. 100-volt battery. Okay. So let's assume you have connected a 100-volt battery across points A and B. You connected a 100-volt battery like this. Yes or no? This is the first thing you will do. Why the first thing? So that a current can flow through the circuit. Hai na? What do you need to do? What do you need to do? You need to find the net resistance and net AB. We already did one question based on this. Guru, don't worry, I'll ask you. Na? Let me just tell you this thing. Basically, if you want to connect it this, so across points A and B, if I connect the net resistance of RAB, it will have the same current which is flowing in the PA. Okay. So basically, I am replacing all these with a single resistance. That will be the net resistance. Right? So how can I calculate the net resistance? RAB which is equals to V by R, V by I.
V by I.
V by.
So just for ease in calculation, don't worry, this will not affect the answer. Okay. Yes. Guru, yes, you were telling me how the current is, how current will be divided. Yes, tell me. Let's say current I is coming from here. Hello. Guru, you can speak now. Ishita, can you tell me how will you distribute the current?
Yeah. So let it pass through on the top, and then from there it's like 2. So that will be I, and the below one I1, and that will be I minus I1. And
Now,
then it'll flow that way, and I minus I1, and then from there it'll flow down.
this I1 will flow down?
No, the I minus I1 will
I minus I1 will flow down and pass through 2 ohm resistor. Now what? I minus I1 came at point Y, I1 came at point X. Now what?
The I minus I1 will go up.
I minus I1 will go up. Won't it go to this 1 ohm battery, 1 ohm resistor?
So there's no current flowing through the 6 ohm?
So let's say a current I1 splits into 2 parts. I2 goes over here and I1 minus I2 comes over here.
I2 comes down, and then it'll join.
So I2 current will go over here and I1
minus I2.
Now what?
It'll be I minus I2.
Okay.
Towards the.
Now this I minus I2 will
go on Top.
go over here, and this I2 will go over here, and they will become how much? They'll become how much? I again. So they became I again. Same current. I. Is this clear?
Sir.
Yes, sir.
So this is how the current distributes. Yes. Can anyone tell me the Kirchhoff's equation now? Basically, what to do now? What to do, guys? I am leaving this as a homework for you. Make the equations. So you'll get 3 equations, right? Which are your variables?
Yeah.
I1 and I2.
I2.
So use any 3 loops. Acha, take the outer loop. This is the outer loop has to be taken as a must. Okay.
Mm.
Take one loop as this outer loop, which is containing the battery. Rest every other thing you can take whatever you want. So 1,
Okay.
2, you got these 3 equations. When you solve those 3 equations, you get I1 and I2, right?
I2.
Yes or no? Once you get the value of I1 and I2, what do you need to find out the net resistance? You need to find out the value of I, right?
I.
So you'll put this value over here and you'll get your answer. Is this clear?
So even if we use like any random voltage like 100, we'll still get the answer?
Yes, even if you use any random voltage, still automatically these answers will come in such a way that this ratio will be the same.
Okay, yeah.
Equals to IR.
Yeah,
The
okay.
voltage, the more the
So,
current, lesser voltage,
okay,
lesser current.
continue.
So can you explain the outer loop once?
Yeah,
Just
outer loop.
Outer loop का अच्छा why to include the outer loop ऐसा कि the
like
equation
कि कैसे करेंगे outer loop?
outer loop की equation बनाते हैं तो let's go from A to this point then Y फिर ऐसे करके with the
अच्छा
battery.
ठीक है ऐसे loop लेना. Fine.
So basically I minus I1 into 2 with a minus sign. फिर उसके बाद minus I minus I2 into 1
Okay, fine.
and then
Plus
100.
Fine, ठीक है.
So this
So
is
if
your
we
outer
take
loop.
the other way around, like if I consider the 5 ohm resistor,
No problem. No problem.
so what all you have to include in that?
So I1 into 5, so minus 5 into I1, minus 3 I2. And again the
Acha,
battery.
bas. And then we don't include 6 ohm there.
No, how I will include 6 ohm there? Acha, are you taking the loop like this?
We can take any
You can
closed
take
loop.
any. You can take any closed loop. But the point is, always take the smallest loop possible. Only you are the one who has to write the equation, right? You are the one who has to solve. So why to increase the size of the loop so that more and more elements can be added? Are you getting my point?
Yes.
So take the loop as small as possible so that at least you have lesser things to write and lesser things to solve. Okay?
Yes, sir.
This is how you do it using KVL. Any doubt? Any doubt, guys?
No, sir.
No, sir.
No.
Then how will we do it using nodal analysis? Again, we'll connect it to what? Again,
A
we'll
battery.
connect it to what? Yes. The first thing first, we'll connect it across a. You'll connect it across
Random voltage.
a 100-volt battery. Just say. If this will be 100 volt, can you tell me the potential at different point? What will be the potential at point?
At A it will be
B will be how?
100. Okay.
B will be 0.
B will be 0. What about A?
100.
100.
What about X and Y? Do you know X and Y?
No.
We'll assume this as X and assume this as Y only. So can you see 100X again? Now, how many variables can you see?
2.
So can you make the equation nodal? Yes. Navina, please make the equation.
Yes, sir. So the total outgoing current from X, it will be X minus 100 by 5 plus X minus Y by 6 plus X minus 0 by 3 is equal to 0.
So basically what we are doing over here is total outgoing current is 0. So can you see X is the potential, 100 is the potential, bigger potential minus smaller potential, then only this current will be outgoing. So X minus 100 divided by resistance. You know this particular thing, no? Current is the potential difference divided by resistance. So you see the potential here is X, potential is 100 and divided by the resistance. Basically you are applying this one. Is it clear? Yes, don't worry. मैं सब clear
Yes,
करूँगा.
sir.
I'll take the extra class and we will clear it.
Yeah, okay, sir.
अभी तो first of all we'll be sending you the video lectures. So, anyways. So yes,
Okay.
Darshana, can you give me the second equation for Y?
Yes, sir.
बोलो बोलो.
Y minus 100 by 2. Y minus 6
minus
sir,
X.
Y minus X by 6. And Y minus 0 by 1 is equal to 0.
Is this clear?
Yes,
This is
sir.
clear. So basically this is your the two equations. One equation will be from here, one equation will be from here. X is equals to something and Y is equals to something. I'm not solving the whole thing, guys. Equations hai, and I have not brought my calculator. Otherwise, I would have solved in front of you. Whatever. I don't want to waste any much more time in equation solving. You people are grown up enough to solve the equation. I still have problems. One more thing, I'm lazy. So how will you find out the net resistance? Net resistance will be calculated by what? You remember net resistance will be
Total
calculated by
potential by current.
100 divided by the net current. So if you have assumed that a current I will flow through here, can you see from here I current will go over here, right? Let's say I2 current
Yes.
goes over here. So basically what is I2? I2 is 100 minus X upon 5, right?
5.
And what is I1? 100 minus Y upon
100 minus Y by 2.
basically this is 100 upon I1 plus I2 and it can be written as 100 upon 100 minus X upon 5 plus 100 minus Y by. Please remember guys, if your answer X and Y is not coming in between 100 and 0, then your answer is wrong. X and Y should be in between 100 and 0. This is one of the tricks, okay, to identify whether you solved it correct or not. Your X and Y should not be greater than 100. Is this clear?
Yes, sir.
Okay. So this is how you do nodal analysis and this is how you deal with unbalanced wheatstone. Please remember, whenever you have unbalanced wheatstone, without thinking anything, directly apply this. Is this clear? Is this clear, guys?
Yes.
Okay.
Yes, sir.
After this, write down the heading. Open circuit Kirchhoff's equation. So now we'll apply the Kirchhoff's equation. We'll learn how to apply the Kirchhoff's equation in open circuit. Okay? Okay, guys.
Yes, sir.
Yes, sir.
Just see the pattern, guys. है ना? What is changed over here? Do you know how to make the Kirchhoff's equation for a loop, right?
Yes, sir.
So there is a slight alteration. Make Kirchhoff's equation in a loop. Slight alterations, and your question will be done. For example, can I take any question from the previous lectures? Suppose, guys, you don't know how to do nodal analysis. Suppose you don't know how to. Let me. Let's take this question. Control C. Guys, do you remember when you solved this question? You obtained that the current flowing through this branch was 0.5 ampere. This 0.5 ampere was passing through 1.5 and nothing was going in this, right? So all this 0.5 ampere it flew through. Hello?
Yes,
I
sir.
remember this thing. This was the question which we discussed in the last class. Anna? Now the question is not to find out the net. Question is to find the potential difference between points P and Q as mentioned in the diagram. Yes, we are taking one question from the what we did already. I'm teaching how to make open circuit Kirchhoff's equation as mentioned in the figure. So this is your point X, and let's say this is your point Y. Can you see the point Y? And I'll just provide with different colors for that. This is your point X, and this is your point Y. Suppose if you know nodal analysis, then so you can answer directly, right? Can you see what is the difference? What is the difference between the potential of these 2 points? 4.5 minus 3, right? Yes or no? No?
Yes, sir.
So
Yes,
whenever
sir.
you know nodal analysis, then there is no need of Kirchhoff's equation, right? But sometimes what will happen, even with the help of nodal analysis, you won't be able to do the problem. Here you can do. Here X is basically 4.5 and Y is basically 3 volt, which we already know. So basically in the question they have asked what, sorry, this is not X. And this is, so here they have asked what is Vp minus V2, and we know the answer is 1.5. But there is a different method, different methodology to find out the potential difference. We can use open circuit Kirchhoff's equation. So where is open circuit Kirchhoff's equation is used to find the potential difference between 2 points in any circuit. But the only condition is you need to do KVL. First, you need to apply the KVL law to find out the current in every direction. and then after that, after doing the KVL, you will analyze between these two points. So now see guys over here. See the slides alternation. Where are you going from? You are going from P to Q, right? Yes or no?
Yeah.
Are you going from P to Q? So it will go like this, and then we'll go up, and then we'll move to point. Okay, this is how we'll do. Go on. Chalega?
Yeah.
So let's start at point P. So VP. Can you see? I started from point P to VP. Now, the first thing which you encounter is basically the 3 ohm resistance, the 3 ohm and 0.5 ampere. In the direction or in the opposite direction?
In the
The
direction.
direction.
Plus or minus?
Minus.
Minus 3 into 0.5.
Yeah.
So when you moved over here, now is there anything? Now this 10 ohm resistor, right? What is the current through this 10 ohm resistor?
Yes.
Yes, sir.
What is the current through this 10 ohm? Was
Zero.
the current which was flowing in this direction? So hence 0 multiplied by 10. Did we reach at point Q?
Yeah.
So if we reached at point Q, then VQ. Can you see when you solve this equation? VP minus VQ will be 1.5.
Mm.
So could you explain this equation once again?
You start from point P, so you write VP,
Okay.
and then you start making the Kirchhoff just like you normally did. In spite of writing it 0, you write it as VQ. See, suppose this equation is continued in a loop, so you will write the same equation VP 3 into this, and ultimately in the final, when you are reaching in the loop, you'll reach to point P again, right? They'll write VP. That and this will get cancelled, right? नहीं पता मैं.
Yeah.
Let's give you another example. Suppose this is the battery, this is the A, this is one more, this is one more. That's it. 6 volt, 3 ohm, 2 ohm, 4 volt. Yes or no? Can anyone write Kirchhoff for me? Normal Kirchhoff equation. Normal Kirchhoff.
Minus 4.
Tell me. The normal Kirchhoff equation. Anyone?
Minus 3i
Minus
Minus 3i
plus 4
plus 4
minus 2
minus 2i. Okay. Plus
plus
6
6.
equals to 0, right? You write like this.
Yeah.
So basically you have started from this point, right? So let me start from this point. VP minus 3i plus 4 minus 2i plus 6 is equals to, did I reach point P again?
So we can't.
VP, hello?
Okay.
So can you
Yeah,
see
no,
this
it's
and
fine.
this gets cancelled and this will be this equation.
Okay.
Okay? So basically we are using the same equation, but in spite of applying it on the loop, we are applying it on general any point.
Okay.
Okay? Even KVL we did the same equation, but since it was a loop, we cancelled these 2 points out, so ultimately it will become this one. Right?
Since we've already included VP, why would we write it once again?
Because we have started from VP and we'll reach at VP again. These are all potential differences. Potential at that point. So whenever you want to give the potential difference between 2 points, that's why we are using it.
So why don't we do that with a cell?
Why don't we?
Do that with a cell or any other element that we start. Why we should be including that element again?
Why are we including that element again? Because this is the point is not an element on the circuit. Any point on the circuit, is it an element on the circuit? Elements are basically these devices, either resistor, inductor, conductor, capacitor. All these are devices, they are termed as the elements. These points are not the elements of the circuit. Okay?
So whenever we take a point on a wire, we need to include.
Yes. So that's why whenever I'll give you one more example. So see just how it is done. These two things are added. Instead of writing in 0, you write the final point, and by starting from directly from here, you start from the point where you are starting actually. So you have to just include the initial and final point. That's it. Chal, give this.
As equal to Q.
Hello, is equals to what?
VQ. Like, why did we write it as equal to then VQ?
Why did it write? Because we didn't apply it for. ये तो मैंने example दिया बेटा. I told कि even for the normal circuits where we are applying KVL, we are writing 0, right? This is your normal KVL,
Yeah.
right? But in
Yeah.
spite of applying the normal KVL, if you apply open circuit Kirchhoff, whenever you apply open circuit Kirchhoff is for between 2 points. I told you, no, open circuit Kirchhoff is to find the potential difference between 2 points in any part of the circuit. Right?
Okay.
So first, sir, in open
Sir, can't hear you, sir.
You can't hear me, anyone? Hello.
Yes, sir, I can hear you.
Can you hear me now?
Yes, sir.
It's like whenever we want to include those 2 points, the final point and the initial point, we have to always include the open circuit. If you don't want to include those points, the closed loop should be there.
League. Oh.
What happened?
What the hell is happening?
No? What just happened?
Sir, nothing.
So, anyway, is this clear? Is this clear, guys?
Sir, I have a doubt.
Bolo.
First we have to use normal Kirchhoff to find current, and then we use the.
No, it's not necessary. Always, this thing will be given. If you are comfortable in nodal, then you won't require open circuit Kirchhoff. For those who are not comfortable in nodal, they will apply normal KVL, and then if potential difference is asked, then they will use open circuit Kirchhoff.
So this is so long. How will we use in competitive?
This is not long, beta. Abhi, once you will get even a practice of, you'll be even solving Kirchhoff within some time.
Of KVL, right?
Yes.
Yes. Okay, fine.
For example, अभी मैं देता हूँ. I'll give you some questions which are based on KVL, but before that, this thing is based on open circuit Kirchhoff. So I think a little bit more clarity on open circuit Kirchhoff in that. Okay. Then we'll do the questions in the next class. So, anyways, potential difference across the terminals of a battery. Terminals of a real battery. You understand what a real battery is, right? I already told
it has
you
some
the
internal
concept.
resistance.
Very good. So basically, I have already told you about this. Now, suppose when no current flows through the battery. So when no current flows through the battery, the potential difference is equal to EMF, right? We have already discussed this thing. So if I have a real battery and E, R, this is your A, this is your B. Can I draw it like E and R? Yes or no? Yes or no? Can I draw it like this? Hello?
Yes, sir.
Can anyone tell me what is the potential difference across points A and B, or potential difference across this real battery? Can you see over here, when no current is passing, we will use open circuit Kirchhoff. See? Not necessary open circuit Kirchhoff can be used anywhere between 2 points. You can see, let's start from point A. Let's start from point A here. Are you going to the positive terminal or the negative terminal? Yes, guys. Tell me, are you going to the positive terminal of the battery or the negative terminal?
Positive terminal.
The positive terminal. ये positive है बड़ा वाला. The positive terminal say you are entering. If you are entering from the positive terminal, then minus A plus or whatever minus 0 multiplied by R. Can you see the current was 0? That was 0 multiplied by R is equals to VB. So can you see from here VA minus VB equals to
equal to E.
can you see the potential difference between 2 points is given by open circuit KVL? Now you understood it better? A little bit better. We'll do some more questions. Now let's say when current flows.
Sir, can you explain it again?
We started from VA. We started from point A.
Okay.
Then we encountered a battery, positive terminals we are entering, hence minus E. Then we encountered this resistance through which the current was 0, hence 0 into R. And then finally we reached that point B, so hence VB. And then we rearrange the equation. Okay?
Okay, sir.
Current flows to the current comes out. Or here basically the battery is supplying the current. Okay? So when battery is applying a current, can I say this is E, R plus minus, and a battery is supplying the current? So can you give me what is the potential difference between these 2 points? Yes, guys, can you give me what is the potential difference between the 2 points?
Yes.
Same way, exact same way. But now the battery is supplying a current. So the same current is passing through. Let's move from A to B. If you don't want to move from A to B, move from B to A. Now, let's move from B to A. Let's move from B to A, please.
VB
VB
minus
Plus E.
We are going in the direction of current plus resistance.
Okay, resistor, sorry.
minus IR,
So minus IR.
then plus E
Plus E
equals
VA.
So VA minus VB, can you see it from here? VA minus VB is minus I. Yes or no?
Yes, sir.
This is your open circuit Kirchhoff. You start from any 2 points. Doesn't matter whether you are going from A to B or B to A. You get the same answer. If you start from A point, you will get VA minus E plus IR is equal to VB. So can you see when you solve it from here and this will go over here? VA minus VB is still equals to V minus I. Can you see over here? They are one the same thing, guys. It doesn't matter where you start. Okay? Shall we go to the last
Yes.
one? The current goes in to the here the current is supplied into the battery. Okay? So whenever current is coming out of the positive terminal, then battery is supplying the current. And whenever current is entering through the positive terminal, that implies current is supplied to the battery. So basically, this is the case. R current. This is your homework. You need to do it exactly just like we did in the previous case. Now current is supplied to the battery. Point A to point B. Apply KVL. Okay, your answer should be that's it for today. We'll do some more questions on open circuit Kirchhoff for your conceptual clarity. Don't worry. I was just introducing the concept of open circuit Kirchhoff, and I'm done with it. We'll do some questions in the next class, and we'll start with symmetry. Okay.
Okay, sir.
All these things are not there in your school portion, by the way. Your school portion is limited only till KVL, and then done.
Till what?
Till KVL.
Oh, okay, fine, yeah.
School portion mein after KVL there is nothing.
So when is my extra class?
Extra class is for Yash.
Yeah.
मैं वो करता हूँ plan. Now we'll plan everything for you. But अभी कल तो
Yeah, so just text me on WhatsApp.
I'll text you on WhatsApp. I'll give the this thing as well. Why you can't hear me my mic? Yes, I can't hear you.
Hello?
Yes.
That's right. I didn't say anything.
Okay. Chalo, ठीक है guys. Thank you very much.
Thank you,
See you
sir.
in the next class.
Thank you, sir.
Thank you, sir.
So you'll send these notes today, right?
Yes, I'll send the previous notes as well as this notes, as well as the meeting.
Thank you, sir.
The recorded lecture.
Thank
So
you.
can you wait for a minute? I'll
Yeah,
get my
sure,
doubt.
sure. I'm waiting for you only. Let me just stop the recording. Okay.